All right, this is a repeat. This is an updated version of a video I did last year, but it's hard to use the name George Washington. Like my friend at home, I call her my wife, she was surprised that I didn't have, she thought that I taught mostly Americans, remember? Yeah? Well, did I tell you this last time, or no, we did my daughter's birthday last time. So I have Germany, Ethiopia, U.S., right? U.S., Lithuania, India, Georgia. What state are you? What state? Texas, Georgia, the United Arab Emirates. Where?
I'm from the United Arab Emirates too.
United Arab Emirates, Egypt. Mohammed is actually from Bahrain, but he doesn't want to admit it. And then we have the Emirates, and then Egypt. Egypt, Kareem? Ethiopia? Egypt. So we have two Americans in this class too, and mostly from around the world, so it's really quite an amazing school. But anyway, all right, it's tough to use the word George Washington and the cherry tree because no one's going to understand what I'm talking about. But anyway, so the Ethiopian knows. Excellent, excellent, excellent. 5 points for the Ethiopian team. Excellent. So anyway, there's somebody. Oh, what was the mass of the axe head? Did we find that out? Can you look that up? We're going to get the mass of the axe head. I didn't write that down. What is it?
2.5 kilograms.
Is that what it said?
Yeah, I think so.
Okay. 2.5, which is very serious. That's a serious axe head. That's like a bag of sugar. Well, more than a bag of sugar. A little more than a bag of sugar. What's 2.2 times 2.5 ish? So 5.5 pounds? 5.5 pounds? Is that what it is? Okay. It's pretty heavy axe head. And he's going to swing at 25 meters per second. All right, for the American crew here, let's see if we can determine what miles per hour that is, okay? So 25 meters per second, and then times what? 360 seconds, right, is 1 hour. Is that okay? Yeah. And then meters, 1,600 meters and 1 mile. What does that equal? So what is 25, take out your calculators, Kennedy, help me out here please. Nobody else seems to be working. 25 times 3,600 divided by 1,600. What is it? 56.25 miles per hour. So he's breaking the speed limit in some states, some roads. He's going seriously fast. Okay. Now, when we do circular motion, you'll see why that makes a little bit more sense, especially if it has a long handle. Okay, you'll see why that makes a little bit more sense. But anyway, let's get rid of that. Okay, is that all right? Just want to get rid of that. So it's 56.25 miles an hour. Okay, you see how I did that? That is not dimensional analysis. That is factor label conversion. People call it dimensional analysis, and I fight that definition. Okay, so he has a tree, and he's going to chop the tree, and he's going to go like this giant axe head, and he's going to go in 2.3 centimeters. So right away, I have something to make sure I convert. What is 2.3 centimeters in meters? 0.002. So divide 2.3 by 1,000, and what do you get?
By 100.
I'm sorry, by 100? 0.023 meters. Okay, 0.023 meters. Now remember, we only use meters, seconds, kilograms, right? So is everything in order? Yes? Now we've got to figure out the force. We want to figure out the force in which he's hitting the tree, and then the force in which the tree is hitting back, right? Yes? So we want F equals MA. we're going to use Newton's second law to solve this problem. Now, we have distance and velocity, correct? Yes? If you look at, we also want acceleration. If you look at the three major equations, do you have them there? The three major motion equations, chapter 4, straight line motion. Remember I gave you three major ones? Which ones did I give you? Shall I write them quickly? Okay, it's been a long time since we've done this. Okay, we spent so much time on projectile motion. Remember we had v squared final equals v initial squared plus what? 2AD. We also had v final equals v initial plus AT. We also had D equals initial velocity T plus 1/2 AT squared. So what equation do you think we're going to use? Which one has everything we need? Either need or not need. We're working with initial velocity, final velocity, distance, and F equals ma. We're also using acceleration. So what equation does it look like I'm going to use? The first one. You see that? How I'm going to use that one? Yes? Those three equations are vital in order to carry out this solution. Yes? Okay. All right, here we go. So, let's solve this equation for acceleration, shall we? And then plug in, is that okay? Can we do that? Yes? So, v naught squared plus 2AD. Okay, now, solve this. So solve for A. What do we get? We get, anybody? What's A? Can you do it mentally? Omar? Hey, for the Egyptian team, you can do it, big guy. This is the Physics Olympics. Who says you have to watch Sochi? You can just watch this video. You going for the gold medal for Egypt? Omar? No? I want to solve for A. They're being very shy. Yes. Anybody? Yes. Nahum?
Would it be like A equals?
All right, A, you want to go that way? Okay, good. So A equals what?
V.
Just think of it this side and flipping it. Just mentally do it.
V.
VF squared minus V naught squared. Is that what you said? Excellent. God bless Ethiopia. Wonderful. Okay. Over 2D. That's right. Okay. Now plug that into the formula here, and what do we get? We get F equals M, and then VF squared minus V naught squared over 2D. Yes? Is that true or not?
Yes.
Is that true? Now let's erase this. All right, now let's plug in. 0 for VF, right? So F equals 2.5 kilograms. And then you're going to have minus what? Minus what?
Minus 25 over 0.
VF is,
I think it's.
I think it's the other one.
Isn't it?
that's supposed to be,
Oh, it's because
No. And then under 2D would be 0.
But is it going to be, this? Or am I going to put the parentheses around the negative sign too?
around
No.
No, I'm not, because this says it's minus that squared. So whatever that is squared, you're subtracting it. So you're not putting the parentheses around the negative sign. Yes? So then that's going to be divided by what?
0.046.
What is it?
0.046.
So 2 times 0.023 No, I heard you. You're absolutely right. Okay, so this is gonna be, can I erase? I don't need to erase anything. So F equals 2.5. Now do this for me. That's gonna be, we're just gonna leave off the unit labels. Is that okay? I always ask permission. Yes, is that okay? So 25 squared is negative 625, right? And that's gonna be divided by 0.46, right? Or no? Am I right?
Yeah.
Yes? Okay. So what's that gonna equal?
Negative 12,961.
Negative 12,961.
961. Not 62.
962.
Yeah, rounded.
Is that right?
Just
12,962, what? Did you do 2.5 times that?
Yeah, yeah. Oh, no.
12?
No.
That's okay. You take your time, big guy.
Negative
2 times
The,
625 divided by 0.046.
the whole answer is negative 3,396.7.
3,000.
396.7,
No.
yeah?
What are you doing? Hold on.
No, man, no.
That's the answer.
Can I say,
That's the answer.
Oh,
Oh.
is it 3,400?
Yeah.
Okay, they're having a problem here. They're saying it's that, which is okay, but let's just round that to 34, is that okay? Just a little easier, a little nicer to play with, yes? So what's it gonna be?
3,400. 3,400, isn't it?
Okay, now. What is that answer? What is that? Remember, this is what we say in here. The direction of the motion, we say, the direction of the motion is going to be positive, right? So, if I apply a force to a door, say, let's say I apply 5 newtons to a door, positive 5 newtons, yes? What's the door going to push back if it doesn't accelerate? 5 newtons, it's going to push back, right? Okay, now, if this is positive 5 newtons pushing this way, yes? What would it be if I put the door pushes back this way? It would be what? It would be negative 5, right? So, what does this negative 3,400 newtons actually mean? Is it the force that the axe is applying to the tree, or the force that the tree is applying to the axe? Yeah, that's the force that the tree is applying to the axe, correct? So what is the force that the axe is applying to the tree? Same thing, not really. It's actually 6,800 newtons difference. Wow. So you're 6,800 newtons off. Well, how does that mean? What does that mean by that? In other words, if the tree is pushing back negative 3,400, right? The axe is pushing positive 3,400, correct? So if the axe is pushing 3,400 this way, and the tree is pushing 3,400 this way, the difference between the two would be 6,800, correct? So, the answer is, let me erase this. I have a little rag here, okay? So you get that, right? Is that easy? Yes? Yes or no? Okay? So, if we're going to say, now this is a great essay problem. It's not enough that you say what the sign is. You have to explain what your answer is. In other words, here's the tree, okay? That's the tree. Okay? And then the axe is going into the tree. Right? The axe is going into the tree. Okay. So, the axe is going 3,400 newtons into the tree, correct? and the tree is pushing back negative 3,400 newtons. Clear? So what you would have to do is, you would have to draw a free body diagram and briefly explain your answer. Clear? So, if we had a quiz, and I said, okay, here's the data. The mass is 2.5 kilograms. The initial velocity is 25 meters per second. You're hitting a tree with an axe, and the axe is going into the tree 2.3 centimeters. What else? Is that all the data there is? All right? You're going to have to figure out that the final velocity is 0. Right? Then you're going to have to calculate it, and you're going to come up with an answer of 3,400 newtons. Now, then you'd have to explain your answer. So you say, well, the direction of the force, we'll say, is positive. Yes? The answer is 3,400, negative 3,400. So you say, if the direction of the motion is positive, then the tree is going to be the opposite to that, or the Newton's, what law is that? Newton's third law, equal and opposite reaction. So how do you know that the tree is applying 3,400 newtons and the axe is applying plus 3,400 newtons? The tree is negative 3,400 newtons and the axe is positive 3,400. How do you know that they're equal and opposite?
Because like it doesn't move.
It doesn't move, it stopped. Newton's first law. Yes, it stopped. It's not accelerating, is it? Stopped. Correct? Yes? So there's no acceleration anymore. Yes? So then you apply Newton's second law to solve the problem, and you apply Newton's third law, which states very, very clearly that if it's negative 3,400, that's going to be the force that the tree is applying to the axe, and then the force that the axe is applying to the tree would be positive 3,400 newtons. Do we understand each other? Do you understand that? Now, I'm going to say this once more. Say this once more. That the videos, if you go to my homepage and you hit where you have physics, chemistry, etc., and you hit YouTube, and you go to that rather lengthy list of YouTube opportunities, and the top ones, you just go to T. Darcy Physics, that will go right to the homepage. Now, on that homepage, there are listed the topics that we do. One of the topics is Newton's laws. So if you go to Newton's laws and you click on that, that brings you to tons of videos that go over every single problem on problem set 3. Okay, now let's put this on record. Okay, the homework is due today, and that's the outline, correct? So today is the what? The 9th, right? And on the 11th, conceptual development is due for the 3 chapters, 3, 6, and 7. On the 13th, next time questions, 3, 6, and 7. On the 17th, the exercises, 3, 6, and 7. On 19th, on Thursday the 19th, it's the problem set 4 is due, and that is 4 chapters, 3, 6, and 7. And book problems are on the 23rd, and the 400-point test is on the 25th. Plus, you'll have quizzes sprinkled in all through there. Clear? Now, on Tuesday, I'm going to give you 3 quizzes. Yes? One's going to be a very simple horizontal motion. Maybe we'll do trying to get Sky, the St. Bernard, out of the house, something very simple. So let's just review what a problem might be, okay? First of all, a problem might be just like what we did today, okay? There's also a problem that it might be, and I'll give you a hint, and it's on the web. It's a card problem where you're sliding a card across a table, That's just a really good hint. Okay, I think actually, if you give me your problem set, where's your problem set? Let's do it. Give me your problem set. Where's your problem set? Right there on your left. Maybe that's where it is.
Which problem was that?
I think problem set, maybe you're right. Maybe it's problem set. All right, let's do a couple of these. Okay. Now we've done Rose sledding down a hill. We did that, right? And we did trying to get Sky out of the house. So give me the next one. Kennedy, may I have that one, please, just for a moment? Thank you.
4.2?
Yes, please. Or 4.2 and 4.3. 4.2 and 4.3. Okay. Mohammed and Amir, thank you for listening. I appreciate your cooperation. It's actually quite wonderful that you would cooperate with me. Okay, so let's look at problem. Now this was at one time my most popular video. I had sunglasses on, I was playing some tunes, you know. And it's called Lifeguard. You ready? You ready? This is on page 50 of the problem set, and this is what we're going to do now. Okay? This one is pretty cool. This is Link, the 65-kilogram lifeguard. All right? And he's sliding down an incline. It's 35 degrees with the horizontal. Okay? We'll call that 35 degrees. And he's sliding down. All right? And we'll call this Link. And he's 65 kilograms, right? And we'll draw like this. It's pretty awful, actually, isn't it? This one will draw straight down. This one will draw This is not working out very well, is it? All of a sudden I can't draw. You know what, let me draw this on the board, just so this isn't that long of a video. Let's stop this and then we'll come back and do another video, okay? And I'll have it all on the board and ready. So this is not that long of a video. And this video is called what? We'll just call it the cherry tree, okay? Yes? Okay.